5 gram ice cube at negative 20 degrees Celsius is in a rigid, sealed container from which all the air has been evacuated. How much heat is required to change this ice cube into steam at 100 degrees Celsius? So what we have in this particular case, we have to do something with the ice to convert the ice completely into the heat, into the steam. Because we have, in this case, to use phase transition, you have to look at the appropriate table in your formula sheet which deals with the phase transition, this particular table. You have to find the substance you are working with, in our case it's a water, and you see that the water experiences two phase transition. At 0 degrees Celsius, it goes from ice to the water. At 100 degrees Celsius, it goes from the water to the steam. So, we will start from our ice cube. We have ice cube at the very beginning. This is ice. We have mass of the ice, which is 5 times 10 to the negative 3 kilograms. We have initial temperature, negative 20 degrees Celsius. Now, we have phase transition, melting of the ice into the water at 0 degrees Celsius. We can find this from our table in our formula sheet. But before we will be able to convert our ice in water, we have to warming up ice, still ice, at to the temperature at which phase transition will occur. So this temperature would be 0 degrees Celsius. So for this particular period, for this particular stage, we have to deposit into the system or add to the system amount of heat Q1 equals specific heat of the ice times mass of the ice times final temperature 0 degrees Celsius minus initial temperature of the ice. Where to find specific heat of the ice? From the table in your formula sheet. If you look at specific heat table, you see the ice which has specific heat 2100 joules per kilogram per degree Celsius. So we will be able to calculate this Q1. Then we have to convert our ice into the water, doing phase transition which occurs at the fixed temperature 0 degrees Celsius. To do that, we have to deposit Q2 into the system, which will be equal to mass times latent heat of the fusion of the ice. We will find this again from the table for the phase transition. This is our latent heat for the fusion, and the value is 3.33 times 10 to the 5th joules per kilogram. Then, having the water, you have to warm up water, still we have water, to the temperature at which another phase transition will occur, at which we'll be able to convert water into the steam. So this temperature is 100 degrees Celsius. Again, you will find this from the same table. So you have to deposit here Q3, which is specific heat of the water, which is 4190 joules per kilogram per degree Celsius, times mass of the water. It's the same as the mass of the ice, because being converted into the water, we do not change mass. And then we'll have final temperature 100 degrees Celsius minus 0 degrees Celsius initial temperature. And finally, we need to convert water into the steam. And to do that, we have to deposit additional first chunk of the energy, which is product of the mass of the water, M, the same as the mass of the ice, times latent heat of vaporization. Latent heat of vaporization, again, you will grab from the same table. For the phase transition, it's 22.6 times 10 to the 5th joules per kilogram. And final answer would be Q1 plus Q2 plus Q3 plus Q4. If you will calculate each of these quantities, add them, you will solve the problem.